I've switched over to this Rigol DS6000 demo board. Off and on I've been using this board and the Siglent board for various signals, but the Siglent board doesn't have the buses. This one does have RS-232, SPI, IIC or I2C, and CAN. CAN won't do us any good because neither of these scopes will decode the CAN, but they are supposed to decode the others. But I've actually decided not to go through the decode and in the trigger section, and instead what I'm going to do is just give you a very quick snapshot of the RS-232 decode in the Siglent for reasons that you'll see, and then I want to just move on and try to wrap everything up. In other words, make this the last video with a little bit of an overview and a summary. So what I have hooked up here is the RS-232 output of this board, and what that generates is the word Rigol followed by DS6000 with the space in between. It generates that in ASCII, RS-232 ASCII, and the codes for that I wrote up here just to help me out a little bit. It's 52, these are the hex values, 49, 47, 4F, and 4C. And if you look up here on the scope, that is what we have displayed. Let me see if I can get it to if you see over here, we have 52, 49, 47, 4F, 4C, 20, that's a space, and then the D of DS continuing. Now, the reason that I decided not to continue with all of the decode functions is, frankly, I didn't check the manual and did not realize that the Siglent apparently does not do an ASCII decode. In other words, it shows you the hex values, and that's all you get. Based on that, and the fact that I know that the analog discovery I've been working with does a much better job of decoding RS-232 signals, I think what I would like to do is, instead of just comparing these two scopes for decode, I'd like to include the analog discovery, and since that's an entirely new topic, I'm going to skip that in this set of videos and do a separate set on comparison of these two scopes versus the analog discovery by Digilent. I'm picking up where I left off in the comparison between the Siglent and the Rigol, that is the Siglent SDS1000, this scope here, and the Rigol DS1000Z. And if you watched part 6 of that set of videos, you'll know that I was in the middle of doing bus decoding when I decided to end that series and move on to a different kind of comparison. And so that's what I'm picking up with here now. You may see what is going on the screen here is pretty much where I left off. That is, I'm decoding an RS-232 bus with the Siglent, and you may notice that I have the list feature turned on, and I'll zoom in here so that you can see it a little better. There we are. And you may recall that the what we were decoding is shown here, and also down at the bottom is the word Rigol followed by a space followed by the DS6000, which is the name of the board that generates the signal that we're using. And so let me show you there is the signal itself on channel 1 of the Siglent, and then down below that is the decode. 52 is of course an R, and then I, G, and so on. And you may also recall, if you watched part 6, that the reason I stopped and decided to change gears is because I discovered, much to my discomfort, that the Siglent does not do an ASCII decode. And so what I wanted to do is to switch to comparing the Siglent with the Rigol. Now what I have set up is the Rigol DS1000Z to decode the same RS-232, and at the top, of course, is the waveform itself, and then down below I have it set actually to decode both the receive and the transmit. There are 2 decoders in the Rigol. There also are 2 in the Siglent. But the difference here, I think, is significant. If you notice, what we have is an actual ASCII decode. That is, the specific ASCII characters are shown, R-I-G-O-L. Now, the Rigol has the ASCII, which the Siglent does not. The Rigol also has the ability to decode RS-232 in binary, hex, or decimal. Now the Siglent, as far as I can tell, only will do hex decoding, so it won't produce this. You can do all of this in a table and some other things that I'm not going to go into at this point, because as far as I'm concerned, the fact that the Rigol allows ASCII, full ASCII decode, and the Siglent does not, means that if you're going to use a scope in an RS-232 decode, then I would say go with the Rigol. I think Siglent needs to rethink their decode options and add an ASCII decode. So that sort of concludes the comparison between these two. I think what I'm going to do now is I'm going to set up a decode on an even better scope, a Rigol 4000, and show you how that decodes an RS-232 bus. And of course it's basically the same decode, it's just that the 4000 is a much better scope and also a much more expensive scope. Now we've set up to do the RS-232 trigger and decode on the DS4000. Let me turn on a little more light here so you can see what we're dealing with. Now the DS4000 is a much better scope than either of the two that I've been comparing otherwise. But I thought I would show you that basically the decode on this one is essentially the same as the one on the much cheaper Rigol DS1000. Once again, the reason that it might be important is if you're doing RS-232 decode work, you don't really need a scope like this. This is actually it's a 300 megahertz or 350 megahertz scope. It actually goes out past 500 megahertz. The 3 dB point is about 516 megahertz compared to a megahertz. But because RS-232 is fairly limited in speed, you don't even really need a fast oscilloscope. The analog discovery that I showed you earlier is perfectly adequate. There is one thing that I thought I might show you, because it's a little trick that helps a lot when you're trying to decode. You want to freeze the data, and the way you do that is you use this run stop button, and you'll notice there the data is kind of flashing by. It's kind of hard to see what it is, and then you stop it. Now what I have found is the best way to do this is to actually increase the sweep speed until the I'm sorry, until the decoder can no longer fit the data into the little packet areas. Then stop the scope and expand it out one. The reason if you do that is now you can use the horizontal position control to scroll through looking at your decode. Now, there is an even better way than this to do the same thing using the record features of scopes like the DS4000. Unfortunately, the DS1000's record feature, while it can be used to do this, it's much harder to use. It doesn't have the scroll features that this scope has. It doesn't have the analyze features, and so on. So for basic RS-232 decoding, the DS1000Z is a good scope in my opinion. If you're doing really complicated stuff where you're looking for errors, random errors in a long RS-232 string, you pretty much have to go to a scope like this, primarily because it has the superior record capability. Not because it's a faster scope, but because the record and analyze features allow you to look at very long strings of RS-232 data and find places where you have exceptions and so on. So I think that about wraps up what I wanted to say about RS-232 decode, and I'm going to end this particular video at this point. I've now set up the Siglent SDS1000 to decode an I2C or an IIC bus. Once again, the data that's being sent is Rigol, and I'm not going to go through the setup on the Siglent because, as you'll see, I really don't consider the decode in the Siglent to be adequate if you're actually working with buses. In other words, it's somewhere between a toy and something you can use, but it does not decode into ASCII or any other format. But let me show you what the screen is showing, and you'll notice that up at the top we have the data, and the data that's being sent is Rigol. Now I'm going to stop the scope so that it will freeze and hold the data, and then we'll move in here and hopefully we can get it to there we are. Okay, and you may notice that on the top line I have it triggering on 52, which is the letter R in ASCII, 52 hex, and across the screen you can see R and then I, G, O, L. That's for F, by the way. It's hard to read, and that's for C. But that is the Rigol that the board is sending, and so it is properly decoding it into hex. However, if you were using this in any kind of a regular environment where you had to decode these buses on a regular basis, I really don't think you would find this to be a satisfactory situation. So once again, I'm going to suggest that just as with the RS-232 decode, the Siglent decode for I2C on this scope is, in my opinion, inadequate. And so I would not buy the decode package for the I2C, just as I wouldn't buy it for the RS-232. So now let's move on to the next, which I think is going to be the Rigol equivalent in the I2C mode. Here is the Rigol DS1000 decoding the I2C bus. Zoom in here first and let you see at the very top is the S clock signal, and the next line down in blue is the SDA signal, and then below that is the decode, and as you can see, it's RIGOL, which is what the board is putting out. Now, once again, as I explained, the Siglent will not do an ASCII decode as this one will. Both the Siglent or the Rigol will do a hex decode, but for reasons that I have stated previously, I really consider it necessary to have an ASCII decode if you're really going to be working with these buses. Now, once again, I'm not going to show the setup on this scope. I'm actually going to compare this now with the Rigol 4000. Basically, the purpose of that is to show that this DS1000, when it comes to SPI decode, just as with RS-232, in my opinion, is every bit as good as the 4000, even though the 4000 costs 4 or 5 times as much. So let me set up to do that, and we'll come back with the Rigol 4000. I have the I2C signal connected to the DS4000. At the top is the S clock. At the bottom is the SDA, channel 1 and channel 2. Now, what I'm going to do on this one is I'm actually going to walk you through the process of doing this. It is exactly the same on this scope as it is on the Rigol DS1000. And the setup is basically 3 steps. The first step is to get the scope into a mode where you can set up the trigger and decode. And all that involves is pressing the auto key. That will get the trigger levels set approximately right for, in this case, channel 1. And what I'm going to do is lower the time base now, that is longer time per division, until you can see what's going on here. And you'll notice there are some gaps, times when the clock is not sending. That's in between each data group. So you now have the scope triggered. I'm going to run it out a little bit. The second thing you want to do is to set up the actual I2C trigger. And to do that, you go to the trigger menu, which is over here. I told you wrong. I hit the trigger mode. The trigger menu is down here. And you may be able to read it. It says type edge. Let me now zoom in a little bit on the screen itself. So you select the type, and then you go down to the I2C, which is there, and you push the multifunction button. That selects I2C trigger. Now you can set up a series of options. SCL, or S clock, is set to channel 1. SDA is set to channel 2. It says start. I'll show you what the options are there. You can have all kinds of different start functions. I suggest that, at least when you're first learning this, that you use the start when start rather than when restart. Restart is the same as start, it's just that it's a start that occurs after a start. So there'll be a start, and then before it finishes, it'll restart. So we're going to do start. We'll now adjust, and you may notice that the trigger level is down here on the SDA, and that's proper. It'll do that automatically for you. That is, when you adjust the trigger button, or the trigger level over here, this control, it will automatically adjust the SDA. You notice the little dotted orange line, the SDA trigger. Now I'm going to slow the sweep down just a little bit more. Then I'm going to go to Decode. Now here is a place where this scope and the DS1000 is slightly different. In this scope, the Decode is right here on the front panel. On the DS1000, it's in the Math menu, but it's basically the same thing. You select Decode, and it asks you what kind of decode do you want. You select that one, go down to I2C. It asks for the bus status. The S clock is channel 1, the SDA is channel 2. The S clock trigger is right there. The SDA trigger is right there, and you may notice that almost immediately up above you start getting data. I'm going to slow that down still further, and you'll notice that it's in hex format. I'm going to do a copy trigger, and then I want to change the format to ASCII. And you'll see, I'm going to go back out. Now I'm going to stop the scope at this point. That is, I'm going to press the run stop key once so that it will stop. You'll notice in the upper corner here it says stop, and you'll see the data that's being displayed. It's the D means data, so data R, data I, data G, O, L, and then a hex 49, and then the R again, and it continues to repeat. So this is the basic way that you set up to decode an I2C bus. In review, it's fairly simple. It's 3 steps. Step 1, press auto. Step 2, set up the trigger for an I2C trigger. Step 3, set up the decode for an I2C decode. And then adjust the various parameters the way you want it. But you will notice that one of the things that's kind of important is that you adjust the time, that is the time per division, so that you get whatever length of packet you want to display. Now, there may be times when you have a very long packet, and as I showed you in another video earlier, in that case, what you want to do is you want to slow the scope down even further and then stop it. At that point, you have many decodes. Now, speed up until you see the part you want, and using the position control, the horizontal position control, move back and forth in this data, as you see there, looking for whatever it is that your particular search is focused on. So in other words here, it has sent Rigol, Rigol, and then there has been a gap. Then it sent Rigol, Rigol again. And so on. By using this technique of going to a very slow scan or very large time per division, stopping the scope, and then increasing or then lowering the time per division or increasing the sweep speed to spread things back out so that you can actually read the decode, you'll find that finding various places in the sequence, particularly if it's a long sequence, will get a lot easier for you. Well, that kind of concludes this. Here I've set up the Rigol. In this case it's the MSO, but the equivalent of the DS1000Z. for an SPI decode. You can see over here we have the decode in the upper right hand corner. The decoder is on. The clock is set to channel 1. That's this yellow line at the top. The MSO, that is master in, slave out, is turned off. Master out, slave in is set to channel 2. And that's this second line in blue. And then the chip select is channel 3. It's not shown on this menu, but it's one further down. And so let's take a look at what we actually have here. So what we have is the clock and data. This is a start signal for an SPI bus, and it's the start signal that occurs when chip select is asserted. In this case, chip select is active low, so it's really chip select bar if you think of it that way. And then down below is the decode in hex. You'll notice that it's the numbers are 97, 97, 97, 97. The way this particular board works is it puts out 4 bytes of data all with the same number. Then it increments that number and puts out 4 more. It will then go into a mode of 2, and it'll put out 2 numbers and so on. I've stopped the scope. You'll see up here that the run stop is stopped, and that's so that I can display just one, because of course this is changing all the time, and so if you don't stop the scope, you're constantly overwriting what you're seeing, and you just see gibberish on the screen. So this is basically the way that the Rigol SPI decoder works. It seems to be pretty easy to use, but I'll point out something that's rather important. You may notice I'm using 3 channels, and to properly decode an SPI bus, you do need 3 channels. Now you also, if you're going to look at the response, in other words the MSO signal, you need 4 channels. So that's one reason that if you're going to do SPI decodes, you really need a 4-channel oscilloscope. And I really don't think that the decode on the Siglent would ever be satisfactory. The reason is you'd be looking at what the master sent out. Then you'd have to reconfigure everything and move a probe around on a 2-channel scope I'm talking about in order to look at the response, that is the MSO, M-I-S-O, instead of the M-O-S-I. By the time you've done that, that signal is long since gone, and so then you have to kind of hope you catch the response, and you'll never be able to display on the scope at the same time the master's signal out and the master signal in, that is the slave's response to the master, on the same scope screen. And so the bottom line of all this is, in my opinion, if you don't have at least 4 channels available to you, it's really kind of pointless to think that you're going to be able to do any serious SPI decoding. This segment should wrap up my comparisons between the Rigol and the Siglent oscilloscopes. You may recall this page from a prior summary at the very beginning, in which I compared the price of the 2 units and also reviewed some of the bugs and other things that I have found. The Rigol only comes in a 4-channel and costs $830. That's the price I verified again this morning on the web. The Siglent, on the other hand, only comes with 2 channels and costs $499. Once again, that's a verified web price. The Rigol, you need to pay an extra $191 if you want to add the advanced triggers. The Siglent, all of the triggers that it comes with are included in the $499 price. And you'll see in a moment that for that reason, I'm actually only comparing the 4-channel Rigol with triggers to the 2-channel Siglent with triggers. as I move forward. Now, there are some bugs that I've previously talked about, and suggest that you go to like the EEV blog for that first one, a bug in a PLL failing to synchronize properly, and as a result there's some jitter. I found some bugs, or at least I consider them bugs, annoyances, whatever you want to call it, in the Windows trigger as well as in some of the measurement functions. But basically, I didn't find any really big bugs. I did discover that the Siglent doesn't decode an ASCII bus into an RS-232 or UART bus into ASCII, but that's not too important unless you're doing work in that particular area. So here is, if you recall, I began comparing these with a focus on university lab experiments, primarily in the areas of communications engineering and embedded digital systems. I've concluded that the Rigol that you ought to be comparing is the Rigol with the advanced triggers. That costs $1,021, whereas the Siglent is $499. Now I have below that the number of channels with an asterisk, and the reason is that to my mind, if you're going to be doing any work that requires, for example, decoding an SPI bus or working with an analog to digital converter or anything of that sort where you have multiple signals, you're really much better off with the 4-channel. However, you do pay a lot more for it, and some of that cost difference isn't just the fact that Rigol separates out its triggers. It also costs more to put 4 channels in an oscilloscope. Okay, down below is sort of my subjective judgment on the various parts of each oscilloscope, and then at the very bottom I'll give you kind of my overall. The vertical systems are very, very close. The reason I gave a slight edge to the Siglent is because of its ability to resolve down to a nanosecond, whereas the Rigol only to 4 nanoseconds, and that's based on public specs. I didn't check that. Horizontal, I give a slight plus to the Rigol, in large part because in the XY mode it will display both the signal and the XY display at the same time, and the Siglent does not. For acquisitions, I gave them both the 6. There are better acquisition systems, but they are in more expensive scopes, and basically I would rate both of them as above average, which, by the way, I'm using a 0 to 10 scale, so 5 is average. The triggers, the reason that I gave 2 numbers to the Rigol is if you don't buy the triggers, I'd give them a 5. If you buy the triggers, I give them an 8, but you pay more. The Siglent, I would give a 7 on triggers. The measurement functions, partly because of the bug or annoyance or whatever you want to call it that I found in the Siglent, I gave it 1 point less than the Rigol. On the math functions, once again, I gave them the Siglent a little less, and the main reason there is because the Rigol has the ability to write a function, a math function, whereas the Siglent does not. I didn't do an FFT comparison, and the reason is these 2 scopes are virtually identical on FFT. They're both above average, and if you're going to be doing FFT, I suggest that you look at some of the videos that were done by Alan, W2AEW, and by MJ Lorton on FFTs in oscilloscopes. They're excellent, and I certainly couldn't do as well. On the display, you may notice I gave the Siglent an extra point, and that's because its ability to do graded as well as color graded display gives it a slight advantage. Overall, I would rate the Rigol and the Siglent as a 7. And I take that into consideration. In doing so, in doing that measure, I didn't use the Decode numbers. The reason is, as I pointed out during that part 7, I don't think I would buy the Decodes for the Siglent. And for the Rigol, they're an expensive add-on. So I would buy an analog discovery. It provides both a generator, that is an arbitrary waveform generator, 2-channel oscilloscope, a bunch of other things. I don't have any connection with Siglent. I don't get anything from them, but I really think this is one of the coming things in particularly electrical engineering education. So I'm going to wrap up at that point. As I said, I'm going to take a little break on doing the oscilloscope work while I finish up this particular segment. Maybe spend a little family time over the holidays. For now, have a nice holiday, a nice new year, and I look forward to seeing you.